Hi, everybody. Thank you so much for joining. My name is Elizabeth E.J. Jamison. I am the Northeast District Forester with the Kansas Forest Service, and today I'm going to be talking to you about emerald ash borer and specifically the impacts on the forest as well as management options. So just a bit more about myself in Kansas Forest Service. I am part of the rural program, and we have 7 different district foresters across the state. I cover the 10 counties in Northeast Kansas. If you're not in my district, you can find the contact information for your forester here at the bottom of the map. But what we do as foresters is we work primarily with private landowners to achieve objectives related to forest health, wildlife habitat, ecosystem restoration, and timber value. So if you have any questions related to forestry, definitely don't be shy and reach out to your foresters. But moving on to our main topic here, emerald ash borer. So this insect is a big deal. It has killed tens of millions of trees across North America, which makes it one of the most destructive invasive species of all time. And there are 3 main reasons for this, for why it is so destructive. First, it is an invasive species, so it is not native to North America. It was first identified in the US in Michigan in 2002, but it likely arrived in the early 1990s. So our trees here did not evolve natural defenses to this pest, unlike ash trees in Asia where EAB is native. So this makes this pest very, very deadly to our native ash trees. Less than 1 in 1,000 trees survive this infestation. And, everybody thinks that it's going to be their one tree in their front yard that's going to survive. But unfortunately, the odds are not in your favor. And then lastly, it has been really effective at spreading across the country. So it is found in 37 states. And here's a map here on the right side showing its distribution. Ash distribution is shown in these green colors, whereas the urban ash distribution is in the yellow colors. And then these dots correspond to the initial county level detection of EAB. So you can see it's pretty widespread here across the eastern United States. Um, but what we're going to do today is focus on the impacts of emerald ash borer on our forests, as well as managing emerald ash borer in our forest settings. So we're going to start with the impacts here, and want to start on a small scale to talk about the impacts on wildlife, and then we'll zoom out more to talk about impacts in riparian areas. Then we'll get into impacts on our future forests, and finally, cultural impacts. So starting with wildlife, like all of our native plants, ash is important for many different species of wildlife. It is fed on by over 300 species of arthropods, 100 of which are dependent on ash in at least one portion of their life cycle. An example here is this waved sphinx moth on the right side. But there are also 32 species of butterflies and moths, 24 species of bugs, 24 species of beetles, and 9 flies that rely on ash. The seeds are also eaten by many different species, including squirrels, mice, duck, turkey, and other birds as well. And then the foliage is browsed on by species like deer and rabbit. So how is EAB going to impact our wildlife? Surprisingly, it might not all be bad, so there are some potential benefits to this insect. First is that EAB itself, especially the larvae, can be a food source for wildlife. So this picture here up in the upper right is of 2 pileated woodpeckers on a standing dead tree called a snag, and they are likely feeding on EAB larvae in this tree, but also on the whole suite of other insects that move into trees once they start to die. Another benefit is that there's going to be more of these snags providing this habitat not only for food, but also for cavity nesters. So there's going to be more of them, at least in the short term, as we have a lot of them dying pretty quickly. And there is going to be more downed wood, also a result of these trees dying. And so that could provide some habitat for species like salamanders here in the bottom right that really like to hang out in those cool, moist conditions under logs. But it's obviously not all good. The death of these trees is going to result in a loss of habitat for the insects that rely on these trees. It's also going to reduce food sources available for wildlife. And although we have a lot of standing deadwood now as a result of EAB, there are probably going to be fewer standing dead trees in the future since we're having them die so quickly at one point in time. So long term, probably not good for trees that, or for wildlife species that rely on having standing deadwood. Okay, let's zoom out a bit and talk about some of the habitats that these wildlife use. So I want to talk about riparian areas, and ash trees are really commonly found in riparian forests. So losing ash in riparian forests is going to result in a lot of impacts. Trees are essentially like giant straws, so they suck up a lot of water. Without ash, the water table may rise, and that's going to prevent tree regeneration and the establishment of other native plants. It's also really going to impact the hydrology, of course, of the area and the nutrient cycling. Also, here's a photo here on the right side of a recreation area in Michigan, and you can just see so many dead ash trees alongside this stream. And so we're going to have a pretty significant loss of shade on water, and that's going to increase water temperatures, and that can have huge impacts on aquatic ecosystems. I love trout fishing, and trout need cool waters. And I don't know if you've ever tried floating on a Kansas river in July, but when there's no shade, it can be pretty miserable. So us as people, we also appreciate having shade on the water. Um, these trees dying means that there's going to be less leaf litter falling into the stream, which can impact stream invertebrates. And then there also might be a slight increase in habitat complexity as these trees die and drop wood into the water. And that can benefit a few different aquatic species. So kind of mixed effects there. But overall, we're going to have some really big erosion concerns as these trees die off and their roots decompose. That's going to, increase likelihood of severe erosion along these waterways. So this insect is going to really significantly impact these riparian areas, and I think we'll see those impacts continuing to worsen as we see more of our ash trees dying here in eastern Kansas. Okay, this is where it gets complicated. So hold on yourself here. I wanted to talk about our future forests. We've talked about how our forests are being impacted today, but this insect is really going to have impacts for how they develop. So I want to talk about biodiversity, invasive species, regeneration, and climate change specifically. So starting with biodiversity, when I use the phrase biodiversity, I'm referring to the diversity of life on Earth from, the species level all the way up to the ecosystem level. And so there are 21 species of ash trees in Central and North America. And we've already talked about how these trees themselves, not only deserve to exist, but they're also connected to countless other plants, animals, and fungi. So losing ash means we are reducing the complexity and redundancy in our forests, and that's going to reduce the forest resiliency and its ability to respond to future stressors. So imagine we have like a new invasive oak borer, get introduced to the United States tomorrow. Our ash trees are not going to be able to help the forest respond to this new disturbance because they're already on their way out. So that's another reason how we can have these kind of buildup of effects that can impact biodiversity. Next up, invasive species. So disturbances like emerald ash borer create opportunities for other invasive species. And we're seeing that especially with bush honeysuckle here in eastern Kansas. So if you look at this photo here in the upper right, you can see how when we have emerald ash borer killing trees in a forest, we have these canopy gaps establishing. And this gap creates a lot of sunlight on the forest floor as it lets in that sunlight. And that's really important for many different processes in the forest, but some species are really good at capitalizing on that additional sunlight, bush honeysuckle being one of them. So unfortunately, we're seeing a lot of areas that were hit really hard with emerald ash borer, and the thing coming up in those gaps is bush honeysuckle. And the photo on the bottom right here is of a forest with a really severe bush honeysuckle infestation. You can see the areas towards the left where the landowner has been clearing this invasive, but here on the right side of the picture, you can just see this green wave. So we're seeing these invasive species really respond well to disturbances like that caused by EAB. I also wanted to talk about regeneration. And regeneration is the process of how forests regenerate themselves, with seeds becoming seedlings, becoming saplings, and then eventually recruiting into the overstory. So this picture on the bottom left is of a forest understory, and it is dominated only almost completely by ash seedlings. And ash is very shade tolerant, so it does really well in very shaded, dense forests with a lot of trees casting shade. Other species like oaks, for example, they don't do so well in those really shaded conditions. They need a little bit more sunlight. Here in Kansas, our forests are very overstocked. There are many more trees in them today than there ever has been. So they tend to be very shaded and very humid. And that is going to favor species like ash over species like oak. So you can see how that's going to be a problem because these little ash seedlings here in the forest understory, they don't really have much of a future. And so these young trees are showing you what the composition of the forest is likely to be like 10, 20, 30, 100 years down the road. And if it's only ash, that's not looking very good. So we need to be managing our forest to make sure that we have trees in there that will be able to survive and persist as a healthy forest in the future. Lastly, gotta talk about climate change, right? The big one, the big bad. When we talk about climate change, we talk about carbon a lot. And ash trees account for about 2.5% of the above ground forest carbon in the lower 48 states. So that is a lot of carbon. So EAB damage is likely to result in an initial loss of carbon as those trees die and decompose, but that may be partially compensated by enhanced growth of other plants after the ash die out and create opportunities for these other plants. So I just hope it's not going to be, just bush honeysuckle getting that opportunity. And then we also talked about biodiversity already, and that impact on forest resilience. But again, reducing our biodiversity is going to decrease that forest resilience, and it's going to make it harder for the forest to respond to future stressors brought on by climate change. So these are just, four of the big ways that this insect is having a really big impact on the future of our forests, as well as what is happening to our forests today. I also wanted to talk about the cultural importance of ash. So black ash in particular is very culturally important for many indigenous communities in the northeastern US and eastern Canada. This tree is used to make baskets, which is an essential way of passing along knowledge in these communities. The tree grows really well in wetlands, which makes the wood very spongy and bendable and really ideal for basketry. And unfortunately, black ash has little to no resistance to EAB, and this obviously presents a real threat to our indigenous communities for them losing relationships to this plant and losing an important part of history and culture. Tribes in such as the Mohawk are doing important work of preserving this species by collecting seeds and planting trees as well. So this kind of brings us to the management portion of the talk. So I wanted to talk about how we are managing the impacts of emerald ash borer. I wanted to start with forest management and then move into policy, surveying, biological controls, and resistance breeding. So forest management. When I say forest management, I just mean managing the forest with a variety of practices to reduce the impact of the insect or to improve that forest resiliency. So there are obviously not effective management opportunities and more effective management solutions. From the not effective standpoint, there is an insecticide that is effective at treating for emerald ash borer, but it is not feasible or realistic at the forest level. We can't treat every single ash tree in the forest. Another not effective method is basal area reduction. This was applied really early on in the infestation, and it was essentially just preemptively thinning the forest and killing ash trees to stop the spread of emerald ash borer. But unfortunately, as you know, this pest has spread regardless of that. So that has not been super highly effective. Now we have to look at our more effective options and what is left for us to do. EAB is here, it's spreading, And the ash trees in our forest today have either already been killed or have a pretty high likelihood of being killed. So our options in areas where there are commercially valuable ash trees and a forest is being managed for timber production, salvage harvests are recommended often to recover some of the value of the trees that have been killed or damaged by EAB. Here in Kansas, we don't have much of a market for ash trees. So what we have had some success with is using silvicultural methods that promote other species over ash. And silviculture is super cool. It's really what I get to do every day. It is defined as the art and science of controlling the growth, establishment, and health of trees. So we do this by prescribing specific practices. So here are two examples on the right side. On the top side, we have a variable density thinning project, and this is where we are thinning the woodlands, killing some of the trees to open up the stand more and get more sunlight on the forest floor. The goal there is to promote some of that vegetation that is less shade tolerant, so species like oaks get more sunlight to those oak seedlings, and hopefully they can recruit into the overstory. So in this case, we're promoting that oak regeneration over ash regeneration. This bottom picture here is of a prescribed fire, actually at Rice Woodlands, which is part of Baldwin Woods, which is maintained and owned by the Keogh Field Station. And so this prescribed fire is many different goals for applying prescribed fire here, but oaks are really highly adapted to fire. And so when we put fire in a woodland, part of the goals is promoting the oak response. So we're trying to shift our species compositions of the forest towards species that are more likely to succeed in the future. And forest management is really tailored to each site and to each landowner's unique goals. So there's not one single solution, but we do have a lot of different tools available to help support our forests. Okay, moving on to policy. Policy is a very important component of battling invasive species. Federal EAB quarantine regulations were stopped in January 2021, primarily because EAB was already so widespread. And so this released 1,198 counties and 35 states from those regulations. State-based programs now regulate the movement of infested materials to try to stop human-facilitated spread. And Kansas Department of Agriculture lifted its quarantine on March 1st, 2021. And so the current focus is education, outreach, survey, and biocontrol. Moving firewood is the primary way that EAB is spread, and it was linked to initial outbreaks in Missouri, Indiana, Colorado, and West Virginia. So although there are no longer any regulations on moving firewood in Kansas that might be infested with EAB, I highly recommend that you don't move firewood across county lines, especially to counties where EAB has not yet been identified. Early detection and monitoring are critical for managing invasive species. Surveying for EAB is primarily done by strategically placing traps to catch the insect in ash trees. And so there are many different traps. There are sticky traps, funnels, and lures, and they're often baited with oils that attract EAB. So surveying in Kansas is done through a collaboration between Kansas Forest Service and the Kansas Department of Agriculture. So you can see the current status of EAB in the state. We had 2 new county detections in 2025 in Pottawatomie and Lynn counties there. So we're really on the western extent of this insect in the country. Once we know where EAB is present, we can start implementing controls. One of the more common control methods these days is a biological control, which is using natural enemies of a pest to reduce the impact of that pest. So there are 4 tiny stingless wasps from EAB's native range in China and Russia that were identified as optimal biological control agents. All 4 of those wasps target and kill EAB specifically. 3 kill EAB by laying their eggs on EAB larvae, and their eggs hatch and feed on the EAB larvae. One of the wasp species kills EAB by laying their eggs on EAB eggs, and like the others, when the larvae hatch, they feed on the EAB eggs. So each of these wasps is optimal for killing EAB under different conditions related to things like temperature and host tree size. In Kansas, biological efforts, control efforts are happening in Lynn, Miami, Osage, and Shawnee counties. So if we go back to the map here, we can really see that that's kind of on the southwest extent of EAB's range in Kansas. So this biological control is just one piece of the puzzle when it comes to controlling EAB. Another piece of the puzzle is resistance breeding. So resistance breeding focuses on developing native ash trees that would be resistant to EAB and would be able to naturally defend themselves against EAB, like the ash trees in EAB's native range. There are two methods of resistance breeding. The first is hybrid breeding, which is where they are crossing North American ash with more resistant Asian ash. And so then the resulting trees are tested, selected, and then back crossed with native ash trees so that only the genes conferring resistance are passed on. There's also traditional breeding, which is where they are searching for and breeding the rare lingering ash tree individuals. And these lingering ash trees are trees that have survived EAB or have survived at least in areas of EAB infestations. So they could simply just be the trees that have stayed alive the longest and have yet to die, or they could also have some level of resistance or tolerance to EAB. So they could be good trees to focus on preserving and breeding. And so this resistance breeding is going to take a lot of time and resources before we get to the point of actually planting EAB resistant trees, but it is going to be an important component of ensuring that our North American ash trees don't just go away. I wanted to kind of close here by just taking a minute to, look ahead. Our forests are facing many, many different novel stressors brought by invasive species like emerald ash borer and climate change. And these stressors are going to interact in both predicted and unpredicted ways to permanently alter our ecosystems. So as a forester, the most impactful thing I can do is to promote healthy and resilient forests that are well suited for taking on these challenges ahead. So here are some resources for the content included in this presentation. And you can learn more about the Kansas Forest Service at kansasforest.org. We also have all the social media. You are also more than welcome to reach out to me directly. So thank you so much for your time, and I hope you enjoyed learning about forest impacts and management options for emerald ash borer.